Dmitry Mendeleev was a Russian scientist. He was also a professor at Petersburg University. Round about 63 elements were discovered during his time. He considered the atomic mass most fundamental property. He also arranged the elements in the increasing order of their atomic masses. Then he transformed this into his periodic table by considering physical properties and chemical properties. According to Mendeleev, the vertical columns are known as groups and the horizontal rows are known as periods. Mendeleev's periodic law is properties of elements are periodic function of their atomic masses. There were also three merits of Mendeleev's periodic table. First, he revised atomic masses. Second, his prediction about the elements which are gonna discovered. Third, zero group. So now let's see in detail what are these three merits. So atomic masses of some elements were revised. They were rechecked by Mendeleev so as to give them proper place in the periodic table. For example, beryllium. Atomic mass of beryllium was 14.9, but after checking its atomic mass, the actual atomic mass was 9.4. So this was the first merit, and the second merit is he kept some vacant places for those elements were yet to be discovered. He predicted some properties of those elements which were undiscovered now, and these properties got to be correct. For example, boron at number 44, for example, scandium actually, at 44 mass. You can see the Mendeleev's periodic table. I'll show it. At that 44, you can see there is there is a vacant place. And that vacant place, he predicted that some element will get discovered in the future and that element will show some similar properties with boron. And so he kept the name of that undiscovered element as boron, which is now said to be scandium. Also, he predicted about aluminium, now it's gallium. Silicon, now it is germanium. Okay, and here's now third merit about zero group. At the time of Mendeleev, noble gases were not discovered. Hence, there was no place for the noble gases in the periodic table. But when noble gases were discovered, it was very simple to place the noble gases in the Mendeleev's periodic table without disturbing the other elements by making another column known as group, right? Another group which was later named as zero group, having all the noble gases aside, and this was a perfect merit. Now let's see what are the demerits of Mendeleev's periodic table. Demerits of Dmitry Mendeleev are just four. Position of cobalt and nickel. The whole number of atomic masses of cobalt and nickel were same. So there was a confusion regarding their sequence, which is to be placed first, cobalt or nickel. So that was just the first demerit. Second demerit is regarding isotopes. Third demerit is regarding the prediction between two heavy elements. And third, the position of hydrogen. So regarding isotopes, isotopes are, what are isotopes? First, let's see what are isotopes. Isotopes are the isotopes having similar chemical properties, but their atomic masses are different. So these isotopes were discovered long after Mendeleev's periodic table. So there was a challenge to place the isotopes in periodic table. And third demerit is about the impossible prediction of elements between two heavy gases. When elements are arranged in increasing order of their atomic masses, the rise in atomic mass was not uniform. So there was a confusion to predict which elements or how many elements are going to be discovered between two heavy elements. And now the fourth demerit is about the position of hydrogen, because hydrogen shows similarity between alkali metals and also the halogens. So let's see what's it. When hydrogen shows similarity with alkali metals, group number 1. When hydrogen reacts with chlorine, it's HCl. When sodium reacts with chlorine, it's NaCl. When hydrogen reacts with oxygen, it's H2O. And when sodium reacts with oxygen, is Na2O. Oxide formulas are same. And here, when hydrogen reacts with halogen gases, halogen is salt-forming elements. When hydrogen reacts with these salt-forming elements, which is group number 7, what happens? Molecular formula of hydrogen and chlorine, H2Cl2. Compound with metals is NaH and NaCl. Since chlorine is NaCl, hydrogen is NaH. They both are compounding with sodium. And compounds with non-metals, CH2 and CCl2, they both are getting compounding with the similar non-metals. Okay, so this was all about the Mendeleev's merit, means Mendeleev's periodic table's merit and Mendeleev's demerits of Mendeleev's periodic table. So just remember, the Mendeleev's periodic table is known as the short form of periodic table, and also the Mendeleev is known as the father. Next, let's get with Henry Mosley's modern periodic table. Henry Mosley was an English scientist. In 1913, Henry Mosley experimented using X-ray tube. He performed and demonstrated that the atomic number corresponds to the positive charge in the nucleus. And according to Henry Mosley, the most fundamental unit or most fundamental property is atomic mass. Not the atomic mass, it's the atomic number. According to Henry Mosley, the most fundamental property is atomic number, not the atomic mass. Till now, 3 scientists tried to classify the elements by keeping their fundamental property atomic masses, but not the Henry Mosley. He tried and got successful with atomic numbers. So, the modern periodic law is properties of elements are periodic function of their atomic numbers. Modern periodic table or Mosley's periodic table is known as the long form of periodic table, and also he arranged the elements in the increasing order of its atomic numbers. And the relation between atomic numbers and electronic configuration is clearly seen in the modern periodic table. So now let's see how's the structure of this modern periodic table. Modern periodic table contains 7 horizontal periods and 18 vertical groups. And due to the formation of periods and groups, it forms boxes. Each box corresponds to the element. Atomic numbers are shown in the upper part of the boxes, and these are in increasing order. Apart from 7 rows, 2 separate rows are also shown at the bottom of the periodic table, which are known as lanthanide and actinide series. There are 118 boxes and which are divided into 4 blocks, which is S, D, P and F. In the S block, 2 groups are there. Group number 1 is known as alkali metals, which are highly reactive metals. Group number 2 contains alkali earth metals, which are reactive metals. P block is from group number 13 to 18. In that, group number 17 contains halogens and group number 18 contains noble gases. D block is from group number 3 to 12 and is known as transition metals. And group number F is nothing but the 2 series which we learned is lanthanide and actinide series. One zigzag line is drawn in the P block. This zigzag line contains or metalloids are around the zigzag lines, and at the left side of zigzag lines are metals and the right side there are non-metals. Metalloids are the elements or Metals having both the characteristics or both the properties of metals and also the non-metals. Modern periodic table and electronic configuration. Electronic configuration within the period goes like this. Neighboring elements differ slightly in their properties, and distance element differ widely in their properties. And in groups, elements with the same groups have similar properties and gradations with the other. Group number 1, which is the alkali metal family of alkali metals, have similar valence. Group number 1 have same number of valence electrons. In group number 2, which are alkali earth metals, they have 2 valence electrons. It means 2 electrons in the outermost shell. In group number 17, which is of halogens, there are 7 valence electrons. It means 7 electrons in the outermost shell of halogen. And as we go down the group, number of shell increases. I'll show you the example ahead. Stay tuned. All elements. Now let's see in the periods. Periods and electronic configuration. So in that, all elements in the same period have same number of shells. And in the modern periodic table, next periods means in the first periodic table, in the first period, first shell will get filled. Like hydrogen, only one shell, so one shell will get filled. In the second period, second shell will get filled. In the third period, third shell will get filled. In the fourth one. So it varies period wise. And in the same period, there is the same number of shells. So as we go from left to right, new electrons start getting added. See, the number of elements in the first 3 periods are determined by the capacity of the shells, electron holding capacity of the shell. So there is one formula, that 2n square. Whatever number of shell you wanted to see, you can just put it in this formula and get your answer. For example, M shell. We know that M shell, it means 3 shells. So 2 into 3 square. It means 9 into 2, 18. So the capacity of M shell, electron holding capacity of M shell is 18. So this was a formula. Now I'm going to share some tricks. Key, the number of shell indicates the period number. And number of valence electrons indicate the group number. And if the element is with more than 2 valence electron, then the group number will be valence electron plus 10. Next, let's go with the reactivity. Reactivity of elements is determined by the number of valence electron. Less number of valence electron, it means the more reactivity. In metals, if there are less number of electrons, the electronic reactivity is more. And in number of valence shell, if the valence shell, means number of valence shell, if metal is there, then the greater number of valence shell will show you the greater reactivity of electrons. Periodic trends in modern periodic table is the last point of this complete lesson. So, periodic trend in the modern periodic table. So, what are trends? Trends are those when properties of elements in periods and groups of the modern periodic table are compared and certain regularity is observed in the variations of them, then it is said to be a trend. So, there are 3 trends in this: valency, radius, and the metallic or non-metallic characters. So, let's start with the valency. Periodic trend valency. Now let's see valency, its variation or regularity in groups. As we observed here, in the same groups, means elements in the same group have same number of valence electrons. So we can say that the valency is constant in the groups. In periods, for period number 2 and 3, as we go from left to right, valency increases by 1 from 1 to 4 and then again decreases from 4 to 0. So this was the first trend, valency. Now second trend is the atomic size. Atomic size is what? Size of atom. Atom is very small, very small. So its size is calculated or measured in picometers. Such a cute word, picometers. And this atomic size is determined by the atomic radius. Now what is atomic radius? Atomic radius is a distance from nucleus to the last shell's electron. This is the atomic radius, and this atomic radius is measured in the picometer. Basically, the 1 picometer is equals to 10 to the power minus 12 meters. Now, variations of atomic sizes in periods goes like this. So, see, basically the one sentence, the atomic sizes in periods goes on decreasing. And the reason is divided in only 4 parts. For remembering or keeping in mind, you just need to concentrate on these 4 parts. In the first thing, number of shell doesn't increases, but the electron increases. It means the shell remains the same, but electron gets increases. And so, in the periods, as we go from left to right, the number of protons or number of positive charge gets increases by 1, and also the electrons get increases by 1. So what happened because of this? Nuclear charge increases and electrons get pulled towards the nucleus, and hence the size goes on decreasing in the periods. First thing, number of shell remains the same, but the electron increases. Due to increasing electrons, the positive charge get increases and the electrons get pulled towards the nucleus, and because of this the atom becomes constricted and atomic size decreases from left to right. Now variations in atomic sizes of groups goes on increasing from up to down. Once more, in groups from top to bottom, the atomic size gets increased. This is because as we go from top to bottom in the groups, new shell gets added, and because of this, the distance from nucleus to the last electron gets increases. That's why the atomic size of the elements or of the atom get increases down the group. And also here, one thing, number of shell increases, but the valence electron or the valency remains the same. Now the third periodic trend is metallic and non-metallic characters. Metallic characters and non-metallic characters in periods goes like this. Wait. Before that, let's see what are metallic characters and what are the non-metallic characters. Metallic characters are also known as electropositivity, whereas non-metallic characters are known as electronegativity. That character, the name given to that character is electronegativity. So let's see what's it. See, in metals, electrons are less. Because of electrons are less, nuclear charge is less. And if the nuclear charge is less, the electrons will get donate easily. And this tendency to donate electrons is known as electropositivity. Whereas in non-metals, electrons are more and nuclear charge is also more. So all the other electrons will get attracted towards the nucleus, and hence the gaining electrons will get more. Its chances of gaining electrons will get more, and the tendency to gain electrons is known as electronegativity. Now the variation of metallic character in periods is like this. If the positive charge on the atom increases, then the nuclear charge will also increase. And because of increasing nuclear charge, all the electrons will get pulled towards the nucleus and donating electrons will decrease. Means this type in periods, they could not be able to donate electrons because they are very close to each other. Because of the electrons getting pulled towards the nucleus, the atomic size decreases. And if the atomic size decreases, then the tendency to gain electron increases. And this tendency is known as electronegativity. Therefore, electropositivity will decrease. Just remember, electropositivity, it means donating electrons. Electronegativity, it means gaining electrons. Just remember that. And now let's see the variations of metallic characters in groups. In the group, as we move from top to bottom, number of shell gets increases. And due to this, nuclear charge, means number of shell get increases. Due to this, number of shell get increases, and due to this, the nuclear force decreases. And that's why the electrons, if the number of shell will increase, the outermost electron or any of the electron, there are more chances to get repelled. Means donating electron becomes easy when the size of the atom is larger. And if the size is more, it means donating electrons, means chances of donating electron will get more. And this tendency to lose electrons is known as electropositivity. So, at the conclusion, I'll just tell you that just remember, electropositivity, it means to lose electrons. Electronegativity, it means to gain electrons. For that, I have just one technique. See, for women, gaining weight is not a positive thing. It's a negative thing. So, gaining electron is a negative thing. And losing weight is a positive thing. So, that was just a funny way to remember it. So, now, last point is, last trend we can also say like that, gradation in halogen family. We know group number 17 is known as a halogen family, and there is a one formula I told you, 2n square. So what happened in this group, as we move from top to bottom, the differences or the variation in the state of matter is visible. See, in the first, which is fluorine, then chlorine, then symbol is Br. You can see the both are the gaseous, then again it comes liquid and solid. So this is not uniform. Gaseous, liquid, solid. This is called gradation. So hope you liked it, and also I have the concept map now. So just look at it.